Hi friends, welcome to GMK tutorials. In this video, we are going to see about the image compression block diagram. So in the last couple of classes, we discussed what is meant by image compression, what is meant by coding redundancy, and what are the different types of coding redundancies are there. Okay, now let's move on to the image compression block diagram, or you can also call it the image compression model. Suppose if we want to compress any image, obviously we need to follow some set of procedure. Then we can reconstruct the same image to the original format. That is a basic realistic nature, right? So in this image compression model, we have two important things is nothing but image compression system is image compression system basically consisting of two important parameters, that is nothing but encoder and second one is nothing but decoder. Okay, these are the two fundamental blocks that are present in the image compression model. So the encoding main importance is nothing but which compresses the information. The encoder performs the compression. So encoder performs the compression operation in case of image compression. Here decoder means that it performs the complement of. So complement of compression. We can also call it a decompression operation. That is a basic question behind the image compression. Okay, let us move on to the block diagram of the image compression. This in this case it consisting of a two parts. So this just the red color line represents the encoder. This block is generally called as a encoder. The below block is represents the decoder. These are the encoder block diagram. This part is encoder. This part is decoder. Okay, so in case of the encoder, basically it consisting of three blocks. One is nothing but mapper, second one is nothing but quantizer, third one is nothing but symbol coder. As well as coming to the decoding process, it consisting mainly two blocks, that is nothing but symbol decoder, and second one is nothing but inverse mapper. Okay, so in case of the image compression, just we are sending the information, that is nothing but f of x comma y is the input image applied to the encoding. So in the encoding process, what happens is that the input image is f of x comma is the input image that is given to the mapper. Okay, so what is the basic function of this mapper means that this mapper transforms the input image to some predefined format designed to reduce the spatial redundancy. That means this mapper main thing is nothing but it transforms the input image to the reduced coding redundancy format. That is a basic behind the mapper output. So for that purpose, we can use the run length coding is the best version to get the very compressed version. So that is a basic example. So what is the next one? The output of the next one is nothing but the output of the mapper is given to the quantizer. Next one is nothing but quantizer. The basic function of the quantizer means that which reduces the accuracy of mapper output. So moreover, this quantizer is also very helpful to maintain the image size and the intensity values within the range we design. That is also one of the important function of the quantizer. Moreover, it also eliminates the irrelevant information. It eliminates the redundant redundant data in mapper output. These are the some of the fundamental advantages of the quantizer. Okay, so in case of the video point of view, we can change the corresponding quantizer output, then we can reduce the output of the mapper output also. Okay, so third one is nothing but in the third stage, that means the third stage, the third component in the encoder is nothing but symbol coder. So in case of the symbol coder, what happens is that the symbol coder generates, that means it generates fixed or variable length code to represent variable length code to represent the quantizer output. That is a basic advantage of the symbol coder. That means obviously based on the quantizer output, it can represent the corresponding number of bits or maybe variable length or maybe fixed length of code to represent the quantizer output. So here we have to follow some procedure: high occurrence outputs with less code as well as less occurrence with high code. Okay, that is the basic behind the how we are going to assign the symbol coder to the corresponding information. So next one is nothing but symbol decoder. That is second one is nothing but decoder. The basic behind the decoder operation is nothing but which is quite opposite to the encoder. It is quite opposite to the So in this case of the decoding process is a quite decompression process. So here also two blocks is there. One is nothing but symbol decoder and inverse mapper. So whatever the one is nothing but symbol decoder. So it is a quite opposite process. Whatever the code words are assigned to the quantizer output, that can be generated opposite of the symbol assigned to the corresponding code. Second thing is nothing but inverse mapper. It is also inverse mapper. So whatever the process followed in the inverse mapper, whatever the mapper performed in the encoding process, that is a quite opposite for decoding process. So based on the symbol decoder, we can decode the corresponding data that is similar to the quantizer output in the encoding process. The same code can be code is used to represent the same number of bits by using the inverse mapper approach. So there is a question mark for each and every one. In case of the encoder, we are using the quantizer, but in case of the decoder, we are not using quantizer. So quantizer is not possible to use because of it is not possible to exactly map the same number of bits in the decoding process. So for that purpose, decoder block does not consisting the any kind of the quantizer in the decoder block. Okay, so there is just a brief introduction about the image compression model. So the image compression is very helpful. So here two important conclusions. One is nothing but suppose f of x comma y is the input image, f dash of x comma y is the output image, or we can also call it the expected image. If suppose f of x comma y is equal to f dash of x comma y, it is nothing but error free or lossless compression. If suppose it is not satisfied, then it is called as a lossy compression. If not lossy compression. That is just a brief introduction about the image compression models. So thank you for watching GMK tutorial, friends. Thanks a lot.